Okay, so welcome to another lesson. So today's lesson, we're going to look at right triangle trigonometry. Right triangle trigonometry. So, but before we go into its details, let's look at what triangles are. Just a brief recap of what triangles are. So, triangles are three-sided figures. Triangles are three-sided figures. So as when we did the area, we saw area of a triangle. So we saw what a triangle was. And then we calculated the area of a triangle. So triangle is a three-sided figure. Sorry. Triangle is a three-sided figure. There are different type of triangles. There are different type of triangles. We have equilateral triangle. So if you talk of equilateral triangle, so let's say we have equilateral triangle, all the sides of that triangle are the same. So like triangle, they have three sides, they have three angles. So if you talk of equilateral triangle, all the three sides are the same. So this side, the length of this, and then the length of this are the same. And then the same to the angle, this angle, and this angle and this angle are the same. And then if you remember about triangles, you know that the sum of the three angles is equal to 180. So if you add this angle plus this angle plus this angle, you should get 180. So equilateral triangle is going to give you 60, 60, 60. So that will be an equilateral triangle. That's going to be an equilateral triangle. I need to increase this so that yeah, it becomes bold. Sorry. So this is an equilateral triangle. All the sides are equal. And then we have what we call isosceles. We have isosceles triangle that have two of the sizes being equal. So isosceles triangle, it have two of the sizes being equal. So this side and this side will be equal. So two of the sizes are equal. That is isosceles triangle. Isosceles triangle. And then we have one which is scalene triangle. You see, this is just a recap because I know you've learned this already. But, and then we have scalene that have none of the sizes. None of the sizes are equal. So we don't have any of the sizes to be equal, and that one is scalene triangle. Scalene triangle. But the one that we're going to talk about today is what is called right triangle. Right triangle. And then this is how a right triangles look like. Right triangle. I need to get this straight. Let me see, do I have a shape here? No, I don't have triangle shapes. I need to draw a straight line. Okay, well, let me erase it. So right triangle. One triangle have a 90 degrees. That's how a right triangle look like. And then it has a 90 degrees. So this is a right triangle. That is what we'll be looking at in this lesson. So, we've talked about the various type of triangle, equilateral, isosceles, scalene, and right triangle. So this lesson, we're going to concentrate on right triangle trigonometry. Right triangle trigonometry. So that is it. So we know about these angles, right triangle trigonometry. That is what we're talking about. We talk equilateral, isosceles, scalene. That's just to review to you about various type of triangle. This is right triangle. That's what we're going to talk about. Let's look at the features of right triangle. The big thing have to look at why is it we call it right. It is 90. It has a 90 degrees. It has a 90 degrees here. So meaning the remaining is going to be 45, 45 if it is an isosceles right triangle. Yeah, so right angle always have 90 degrees. There are some things that we're going to look at, and then I want you to know we have what is called, okay, well, I'll mention that later. So now let's look at we have a theory with right triangle, which is called the Pythagoras theorem. The Pythagoras theorem. So let's look at the Pythagoras theorem before we go into the trigonometry. Pythagorean, the, the Pythagorean theorem. I'm going to explain this theory to you. So all you need to do is listen and then know how this theory works. It's very simple. So if you have a right, let me take this up, Pythagoras theorem. So if you have a right triangle, this is 90 degrees. So let's label A. This side is A, and this side is B, and this side is C. This side is called hypotenuse. The longest side is called the hypotenuse, and then that faces the angle, the 90 degrees angle. It's called hypotenuse. Hypotenuse that faces the 90 degrees. This is called hypotenuse. Faces it. The theorem says that the hypotenuse square, so this C square is equal to A square plus B square. C square is equal to A square plus B square. That is the Pythagoras theorem. This is what the theory says. We're not going to use this one in our lesson, but like you may use it in some of the calculation. You may apply it. You may apply it. So you need to know it. That's why I mentioned it. So take note of it. We are not going to work examples on it, but just take note of the Pythagoras theorem, Pythagorean theorem, that the C square is equal to a squared plus b squared. Just take note of it. Just take note of it. So now we're going to look at the trigonometry. Trigonometry. There's a simple way of learning this trigonometry, and then I'm going to show you that simple way. So if you learn that simple way, you'll be able to solve all trigonometry questions. You'll be able to solve all trigonometry questions. So let me put a right triangle again. Right triangle should always have the 90 degrees. Right triangle should always have the 90 degrees. And then we're going to define the terms. We're going to define the term. Like the first one with like the side. The first one we talked about it already, that the side that faces the 90 degrees is called hypotenuse. I mentioned it earlier on. So always the side that is facing the 90 degrees is called hypotenuse. So note that. So if you have any right triangle, look for the 90 degrees. And then the side that faces the 90 degrees is the hypotenuse. Take note of it, you'll be using it. You'll be using it. And then, you see, so now we have a 90 degrees angle there. And then we have another angle here. We have one angle here. And then we have another angle here. So now, to know the other side, the other sides are called opposite and adjacent. But any of those sides could be called opposite, any of those sides could be called adjacent, depending on which angle you are working with. So take note of it. We have opposite and adjacent, but any side, this side could be called opposite, it could be called adjacent. This side could be called opposite, it could be called adjacent. But it depends on the angles you are working with. If you are working with this angle, or if you are working with this angle, and I'm going to explain that in a minute. So now if you are working with the red angle, the opposite is the side that faces the angle you are working. So here become opposite. And then the side adjacent. The side just so this side become adjacent. So take note of this. This is very important. This confused a lot of students. But now, if I'm talking about this blue angle here, then this side become my opposite. And then this side become my adjacent. So take notes. Look at it well. The hypotenuse does not change. It always faces the 90 degrees. It always faces the 90 degrees. So the side opposite to the 90 degrees or the right angle. The 90 degrees is the same as right angle. That side is the hypotenuse. And now to know the opposite and then the adjacent, we consider the angle. So the angle you are talking of or you are considering in the right triangle, the side which is opposite it, or you could say across it or opposite it, is the opposite. And then the other side become the adjacent. The other side become the adjacent. So this is very simple. This is very simple. So let's look at some example here. So if I have this right triangle, and then I have an angle here, theta. Let's go theta. I have an angle theta here. This is my 90 degrees. This is my right angle. Always have this sign to show that that's the right angle. And then, so if this is my right angle, obviously this is my hypotenuse. Let's use H to represent hypotenuse. So let's say H for hypotenuse, O for opposite, and then A for adjacent, and then A for adjacent. So this opposite. So here in this case, where is my opposite going to be? Just think of it, and then you know that the opposite is going to be over here, and then here will be adjacent. The opposite is going to be here, and here will be adjacent. So if I have a triangle like this, if I have a triangle like this, and then I have my angle here, let's say alpha here, this is always my hypotenuse. So my opposite is going to be here, and then my adjacent is going to be here. Adjacent is going to be here. So take note of this. This is very important in what we are coming to do. If you miss this part, what we're coming to do will be very difficult for you. So make sure that you understand this part very well. Do not miss this part. Do not miss this part. So going over quickly with you, we talk of a right triangle. We talk of a right triangle. That is a right triangle. It's a type of triangle which has a 90 degrees. Just a 90 degrees. And then we saw that we have the Pythagoras theorem. The 90 degrees, the side of the triangle that faces the 90 degrees, the 90 degree, the right angle, is called hypotenuse. The other sides are there, but the square of the hypotenuse is equal to the square of one side plus the square of the other side. That is the Pythagoras theorem. This is a theorem. The proof is there, but we are not studying Pythagoras theorem, so I'm not proving it to show how that came about. Now we come here, we're looking at the right triangle, and then the size, the name given to it. So we have hypotenuse, opposite, and then adjacent. The hypotenuse is always the side that faces the 90 degrees, so that is always there. But for opposite and adjacent, it will depend on the angle that you are talking of or you are considering in your question. So if you are considering this angle here, this angle that has been marked with red, this angle here, then here will be opposite. This side is going to be opposite. But if you are considering this angle, then this side is going to be opposite. So if you get your hypotenuse, you get your opposite, the other side is the adjacent. That side is the adjacent. So considering this triangle over here, if you are considering this angle, then here will be opposite. This is 90 degrees, so always here is the hypotenuse. Here is the hypotenuse. And then here will be opposite and this will be adjacent. If we consider this angle here, the angle over here, which I name it alpha, here is going to be the opposite because that faces the angle. This is the 90 degrees, so this line is going to be the hypotenuse, and then the other side is going to be the adjacent. That side is going to be the adjacent. So this is very, 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 very important. It is very, very important. Now, with this one, we're going to look at the trig ratios. We're going to look at the trig ratios. We first look at the tangent ratio. The tangent ratio. The tangent ratio. That is what we're going to look at. That's what we are going to look at. We have the tangent ratio, the sine ratio, and then the cosine ratio. There are other ratios that we may not look at the secondary ratio, but we're looking at the basic. Yeah, we will not look at the secondary ratios. We are only looking at the basic ratios. We are only looking at the basic ratio. So we have trigonometry, basic trigonometry ratio. Yeah, basic trig ratio. You can say trigonometry, trigonometry ratios. For the sake of our lessons, and then that is what many people do. Instead of saying the whole trigonometry, I'll just say trig, T-R-I-G, trig ratio. So we look at the tangents. We look at the tangent ratio, tangent. And then we look at the cosine. I don't know if you've heard of these words before. We look at the tangent. We look at, okay, sine. And then we look at cosine. Cosine. In short, you hear tan. So if you hear tan, I mean tangent. If you hear sine, I mean sine. And then if you hear cos, then cosine. So you may be hearing tan, sine, cos instead of tangent, sine, and then cosine. So if you hear sine, tan, sine, cos. So the first one we're going to look at is the tangent ratio. Tangent ratio. So what did I ask you to remember? Don't forget that is your right triangle, and then the names they have. So this is my right triangle. If I'm talking of this angle, this is my hypotenuse, this is my opposite, and this is my adjacent. So this is how this ratio, and then you know what a ratio is. You know what a ratio is, like over something. You are comparing something. We use this simple acronym, what we call SO ka twa. So ka twa. we use this acronym to work those three ratios: tan, sine, and cosine. And I'm going to explain it to you. So we have so, which is for sine. We have ka, we have ka, which is for cosine, and then we have twa, which is for tan. Let me just do cos so that you don't get confused, because yeah, which is for tan. If you remember, hypotenuse, opposite, adjacent. S is for sine, C is for cos, T is for tan. So this 0 here is opposite, H is hypotenuse, A is adjacent, H is opposite, O is opposite H, A is adjacent. So if I'm looking for the tan of an angle, then it's going to be the opposite of that triangle over the adjacent. The opposite divided by the adjacent will give me the tan of that angle. So let's see an example. So if I have a triangle, a right triangle, not just ordinary triangle. You can work it with any other triangle, but that is advanced. I don't, that is, and then let's say here is 30 degrees. So if here is 30, we know here is 90, so here will be 60 degrees. At times you have to know that. You will not be given, but you have to know that obviously the right angle is 90. So if they say here is 30, you know that here should be 60, because you know this plus this, this plus this plus this should give you 180. So if you know this, you should be able to know this. So now I want to find the tan of the 30. I want to find the tan of the 30. So what I have to label it. So if I'm looking for the tan of 30, then it means here is going to be my opposite, and here is going to be my adjacent, and here is going to be my hypotenuse. So tan 30 is equal to, we talk of tan to be what? Twa. Opposite over adjacent. Opposite over adjacent. So that is tan. Opposite over adjacent. So whatever measure is here, then that is what is going to be for the tan 30. It's going to be for the tan 30. Opposite over adjacent. So that is it. Now let me do it and put some figures there, and then we'll be able to look, work it. So now we know that tan is equal to opposite over adjacent. Let me try one, and then let me put numbers there. This is 90. So now let's say here is 20, here is 12, and then here is 16. This is A, this is B, and this is C. A, B, C. You should also know that, like how I've labeled it. So if I say angle B, I'm talking about this angle. If I say angle B, I'm talking about this angle. If I say angle C, I'm talking about this angle. If I say angle A, then that is the right angle. I'm talking about the right angle. About the right angle. So if I want to find the tan of B, so tan B, I'm talking of this angle. And I know tan twa. Just always remember your SOHCAHTOA. SOHCAHTOA. So opposite over adjacent. So O over A. So I quickly look at it and say, okay, well, then this is my hypotenuse. This is my hypotenuse, right? And I'm looking at this angle. So it is my opposite and this is my adjacent. It's my opposite, and this is my adjacent. So that is going to give me 12 out of 16. Tan B is equal to 12 out of 16. That is tan B. Tan B, 12 out of 16. What of tan C? Tan C, what do you think tan C is going to be? So tan C, so this angle, I'm talking of this angle. So here is my opposite and here is my adjacent. So tan C is going to give me 16 over 12. So that is tan C. That is tan C. So that is for tan C. That is for tan C. Yeah. So we'll look at let's look at one more example. I think, yeah, I just have to give you this example. So now we only look at tan. So let me give you this example for you to try. We have this cute triangle over here. It's a very cute one. Your 90 degrees is here. No, these are not drawn to scale, so you just your 90 degrees. And then let me label here N, M, and then L. ML is 12, NM is 5, and then NL is 13. So now I want you to find tan L and then find tan N. So what will be tan L and what will be tan N? So that is what I want you to do. So do that, tan N, tan L, and then tan N. Do that, and then let's see. Let me give you more examples. So this is one. Let me give you 3 examples. So this is this is not example, this is our 1, 2. Let me find a cute one here. I have this cute red. Um, let's say here is 5, here is 4, A, B, C. So this is your 90 degrees. What is going to be tan A, and what is going to be tan C? So I want you to find tan A, and then I want you to find tan C. You to find tan C. And then the last one, 3. Sorry, I'm not drawing it straight, but they shouldn't be that. It shouldn't be that. But so let's say 5, 3, 4. Q R S. What will be tan R and what will be tan S? So these are the questions you should do. Let me go over everything quickly with you, and then you look at it. So this is all that we've gone through with right triangle. I explained recap of triangles. We took equilateral, isosceles, scaling, and then the actual right triangle that we're looking at, we said a right angle should always have a 90 degrees. And then we talk of the Pythagoras theorem, which you may not necessarily use it in today's lesson, that the side opposite to the right angle, the 90 degrees, is always the hypotenuse. The other side, you can label it that way, but the other side square, the sum of the other side is equal to the sum of the square of the other side is equal to the square of the hypotenuse. So now you know what hypotenuse is. And then the other side, which is opposite and adjacent, the hypotenuse is always, like I would say, constant, because the 90 degrees, you look at the 90 degrees, and then what is opposite the 90 degrees is the hypotenuse. So you know that, you just look at it and know that. And then the angle you are talking of, because the opposite and adjacent could be any side. So it depending on the angle you are talking. So if you are talking of this angle, here become your opposite, the line opposite to the angle you are talking of. And then the other becomes the adjacent. If you are talking of this angle, here becomes your opposite. So you know your hypotenuse, your opposite, your adjacent, and how to identify them. So this is just an example for you. So if the angle is here, here is going to be opposite. Here is going to be adjacent. If the angle is here, here is going to be the opposite, and here is going to be the adjacent. Now, talking of the trig ratio, we're just looking at the first trig ratio, the tangent, the sine, and then the cosine. Tan, sine, and cos. So looking at the right triangle, and with its label, now I'm considering this angle. So here is my opposite, here is my adjacent, and here is my hypotenuse. We use this acronym. SOHCAHTOA. So SOHCAHTOA. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. What we are looking today is only the tangent ratio. So we're looking at, so all the example we did today is just the tangent ratio. So I look at this one, and then if I want to, the tan of 30 is going to give me my opposite over the adjacent, so O over A. I did not do the tan. So the tan of 62 is going to give you opposite over adjacent, A over A. A over O. A over O. So that is it. So we did an example here with this triangle here, ABC, with sizes 16, 12, and 20. So the tan of B, which is opposite over adjacent. So if this is B, 12 is the opposite. So 12, and then 16 is the adjacent, 12 over 16. And then the tan of C, so here will be my, oh, sorry, that was not on the screen. So we look at this triangle. It have a hypotenuse of 20, and then the one side is AB is 16 and AC is 12. So if I'm looking at the tan of B, because my opposite, which is 12, over my adjacent, which is 16. If I'm looking at the tan of C, my opposite, which is 16, over my adjacent, which is 12. So that is what I have here. So to calculate for the tan, you remember TOA. You remember TOA, opposite over adjacent, which is tan. So this is an example here, 3 examples here I want you to look at. So now I have these examples that I want you to look at them. So after going through this lesson, I want you to work out these examples and then I will check them out. So we continue with calculating with the tan, and then after that we move on to sine and cosine another time. So then do not hesitate to ask any question if you have it.